Hi, hello, good evening, everyone. Welcome to India's largest e-learning platform, Gradeup, and welcome to the session Strategic Study Series. Today, we will continue the discussion of cache memory. All right. So join the session quickly and mark your presence, guys. This is quick detail about me. I am Satya Narayana with all these credentials. These are the subjects I teach: computer organization and architecture, computer networks, operating systems, programming and data structures, algorithms. All right. So guys, the third grade up national scholarship test is going to happen on February 28th for all the branches like mechanical, civil, electrical, electronics and computer science. Attend this grade up national scholarship test and get a chance to win 1 crore worth of scholarship. So try to circulate about this GNST as much as possible. And guys, those who have joined, please mark your presence. Let me know who have joined. And after GATE, what you are supposed to do, how you can plan your career or your selection of IIT or NIT, what are the opportunities after GATE. So everything you can know by attending this post GATE guidance series, which is at 7 p.m. daily on Gradeup. So without fail, please attend this post GATE guidance series, guys. And for computer science and engineering students, we have launched a new batch on 15th February in which there will be 600 plus hours of live classes, 5000 plus practice questions, 100 plus mock tests, 100 plus chapter wise study notes. So everything that you get to crack the GATE exam. And this is the series happening. This is my series happening on Gradeup app at 6 p.m. Today we have discussed the topic BFS versus DFS. Tomorrow is very important topic, very important to attend because there will be a mock test on data structures. So without fail, attend this mini mock test and assess yourself. All right. And this is what the series currently you are watching, strategic study series. This is the today's topic, cache memory part 2, and tomorrow we will discuss cache memory part 3, and on the day after tomorrow there will be a mini mock test on COA. So without fail, continuously attend the sessions, gain the knowledge, crack the competitive exams. Very simple. Okay. So let us start. In the last class, we have discussed about what is cache memory, what is the purpose of cache memory, and what are different types of cache misses, what is the locality of reference principle, and then this write policy and replacement policy. And we were discussing about mapping techniques. What is mapping? Basically, mapping refers to what? The process of address translation. Generally, when a content is copied from one memory to another memory, definitely address gets translated, isn't it? Here the content is copied from where to where? From main memory to cache memory, the content is getting copied. From main memory to cache memory, the content is getting copied. Hi Prashant, GATE CS 46.7 marks RA. Okay, very good. कितने रैंक आ सकते? बट रैंक तो थोड़ा बड़ा नंबर ही आ सकता, मे बी 4 डिजिट रैंक तो मिलेगा मेरे हिसाब से अराउंड. बट वेयर यू आर एक्सपेक्टिंग द admission? Prashant Tiwari. Abhishek Nayak, good evening. Right. So guys, from where to where the content is getting copied? From main memory to cache memory. Now, when a content copy from one place to another place, there is a possibility of address translation. So this is what we call as mapping. Now, what are different mapping techniques? The cache mapping techniques. What are they? There are 3 types of mapping techniques. Direct mapping, associative mapping, and set associative mapping. Why we call these mapping techniques also as placement policies? Why? What is this placement policy says? Here is the cache memory, let's say divided into 8 blocks. Every block is having words. Whenever you copy some block, a block from main memory to cache memory, in these many free blocks, in which block it gets copied? In which block this gets copied? That is what decided. So the place in cache memory is decided by these policies. That's why we call this as placement policy. Placement policy. Now let's see how it works. First, with direct mapping. According to direct mapping, the location of a block, X copied from main memory to cache memory is given as cache memory location for X is given as K modulus n block. K modulus n block. What is K? K says main memory block number. And what is n? Number of cache blocks. Okay, let's see. Suppose there is a main memory with 128 blocks. Numbered from 0 to 127. Let us assume there are 128 blocks. Main memory. but we know cache memory will be small. Prashant Tiwari, no, don't expect. Sorry to say, you may get little more. But under 5,000 you will get. Let us suppose there are 16 cache blocks numbered from 0 to 15. Okay. Now, good evening, technical learning. Now, we know every block is copied, partitioned into words. Let's say CPU wants some J. J is one of the word from the block number 2. So, how do you get this location of J in cache memory? Okay. How do you get the location of J in cache memory? This is given as K mod N block. What is K? Main memory block number for J. J main memory block number is 2. So this would be given as 2 modulus. N is what? Number of cache blocks. How many? 16. So 2 modulus 16, remainder is 2. So in block 2, this gets copied. So the entire block, let's say I, J, K, so on to P. So as it is, that entire block will be copied into block number 2 of cache memory. Let's say there is some other block which is at let's say 92nd block. Okay, CPU requested A. So how do you find the location of A in cache memory? A main memory block number is 92 modulus 16. So where this gets copied? Into block number 12. Lalit Kumar, good evening. Prashant, yes, there is a possibility, Prashant. In NIT you may get. That possibility is there. But in the popular NIT like NIT Warangal or VNIT or Hamirpur, Varanasi, there are some top NITs. No, better not to expect the top 4-5 NITs, but later you can definitely get. But here the meaning of top doesn't mean other NITs are bad. NIT is always NIT, the standards are always good. They are old established institutes. Venkatesh, you may try in Triple IT Hyderabad. You may try in Triple IT Hyderabad, Venkatesh. Or NITI Mumbai. Yeah, VIT is good. Bits is good. Fine. Like this, main memory block number modulus number of cache blocks. When you do, you will get in which block we have to copy this arrived one. We will understand. This is according to direct mapping. Here let us suppose you have got a block U, V, W, X, Y, Z. Suppose CPU is asking for the word W. So the location of word W, how do you get? That is 108 modulus 16. So what you do, what you will get? Block 12. See this. Word A, that A block should be in block 12. W block also should be in block 12. So what happens? The W block replace the A block. So if you can place W block, you can't place A block. If you can place A block, you can't place W block, because both should be mapped to block 12 only. Now, so in A and W, for either of the words, what occurs? Miss occurs. Because if it can hold one, other it cannot hold. This miss is called conflict miss. Why we call this as conflict miss? Because there are many other free blocks, but still W block want to be placed in block 12 only. A block want to be placed in block 12 only, though there are many other free blocks. Why? Because this is due to direct mapping policy. Due to direct mapping policy. So it is the internal conflict between the policies of itself. That's why we call this as a conflict miss. So there is a conflict of block number between W block, W word and A word. So definitely for one miss occurs. Right? Rehan, good evening. Chetan Bansal, good evening. So this is what direct mapping thing. Now guys, CPU always generates main memory address. For each word. This we have discussed in the last class. So if there are 2 power I words in main memory, I bit address will be generated by CPU for every word. Right? So that CPU generated main memory address, that CPU generated main memory address, the direct mapped cache interpret as tag, block or line offset, word offset. Tag, line or block offset, word offset. CPU don't give address like this. CPU just give word address of I bit. That I bit address direct mapped cache understand in this way. What this word offset indicates? Word offset indicates block size. That means number of words in a block. So if there are 2 power x words in a block, That means X bit would be required for word offset. Then what is this block offset or line offset? Block offset or line offset indicates cache memory size. That means number of blocks in a cache. If there are 2 power y blocks in a cache, that means y bits will be required for block offset. Remaining will be for tag. What is a tag? If it is a direct mapped cache memory maintain the page number of main memory. The page number of main memory as a tag. What is this page number concept? Let us understand. Let's say this is the main memory with 128 blocks. Okay. This is cache memory with 16 blocks. Numbered from 0 to 15. There are 4 words in every block. Assume how many words in every block? 4 words. Now, total number of words in main memory are how many? Total words in main memory will be, there are 128 blocks. In every block there are 4 words. So that is 512, right? 512 words, which is 2 power 9 words. That is 9-bit address. So every word will have 9-bit address. Satyanarayana, that is what post-gate guidance series we are doing. If you get this rank, what you can do, where you can apply, and if you are not qualified, what you can do, what are the opportunities you have. We are doing it, experts are telling you. So attend that post-gate guidance series at 7 p.m. on the Gradeup app. Okay. So there will be 9-bit address. Now, when this is a direct mapped cache, how DM cache view main memory means as groups of cache memories. How many blocks in cache memory? 16 blocks. So, every 16 blocks, of main memory is assumed to be one group. 16 to 31. So this is assumed to be another group. 32 to 47. This is assumed to be another group. Like this, How many groups will be there? We will see. This group is called page. So the main memory is interpreted by DM cache as groups of cache memories. Groups of cache memories. As here there are 16 blocks in cache, main memory is also assumed to be groups of 16 blocks. That group is called page. So how many pages we say? Number of pages in main memory is equal to total blocks are 128 and in every group there are 16. So this would be what? 8 pages. So numbered from page 0 to page 7. Now suppose we are copying the word X from block 2. So where you copy location of X, you write as 2 mod 16, that is block 2. So you will copy that here, W, X, Y, Z. Once that block is copied, for easy identification or searching, to make the searching time less, any cache memory maintain index. In a book, how we see index to find something very quickly, in the same way cache maintain an index field called tag for every block. Tag will be there for each block. What is maintained as tag by DM cache? Page number. From which page this is copied? Page 0. Total how many pages are there? 8 pages. That means 2 cube pages. So there will be 3-bit number per page. This is 000, 001, 010, so on to 111. Right? So from which page word X is copied? Page 0. That is maintained as a tag by the DM cache. Will it maintain for only block 2? No. DM cache speciality is it maintain the same tag for all the blocks. For all the blocks it maintain the same tag. Suppose there is a word IJKL, CPU is requesting K. So how you get C of K? C of K is equal to, let's say this is from some 40. So 40 modulus 16. So this would be in block 8. Right? So this is block 8. So IJKL block as it is copied here. And what was the initial tag? 000. From which page it is copied? From page 2 it is copied. So all the tags are updated to page 2. 010, 010, 010, 010, including X block tag also. This is how DM cache works. Sir, you may get a doubt. Sir, why DM cache is doing like this? X page is not 0, no, but why it is X page is 0, no, but why it is updating it to 2? Because whenever CPU generate the address, what DM cache do? DM cache do this partition, word offset, block offset, tag. Take the cache tag and compare with its tag. Right? So cache tag is compared with address tag. If cache tag and address tag matches, that is what we call as cache hit in DM. Otherwise, cache miss. But in this way, to identify whether the cache is there, block is there or not, it will not be appropriate because the tag maintenance is not appropriate. So miss may occur ultimately because thinking that there is the block is there in the cache, later it may not be found. So that miss also we call as conflict miss. But how many tag comparisons are needed? How many tag comparisons are needed in DM? Number of tag comparisons needed will be just one. Why? At any given time, all the tag will be same for DM. For all the blocks, tag will be same. So if you compare with the first tag, that means you compared with everything because all are same. So now the time taken, I will write here, the time taken by cache memory to produce hit or miss. This is status of request. Is it a hit or miss? That is what we call as hit latency or hit delay or settling time. So in the DM cache, only one tag comparison is there. Hence, hit latency is very, very less. But what is the drawback? Conflict misses are high because of the replacements, because of the improper tag maintenance. That's why we move on to associative mapping. Let's see what is associative mapping. Before that, take super subscription in the February because there is a lucky draw happening where you can win smartwatch, laptops, smartphones, scooty, more exciting gifts, guys. So just for your better idea, just watch this. All right. So what is associative mapping? Associative mapping says that the word from some block in main memory can be copied to, here I can say the main memory block can be copied to any cache block, any free cache block. there is no restriction that it should be copied to only that particular block. So if you take some main memory here, with 128 blocks and cache memory of 16 blocks, numbered from 0 to 15, let's say there are 4 words in every block. Now if X is requested, not only X copied, we know according to spatial locality whole block is copied, where it can be copied anywhere. So I am copying, let's say, in 7. Suppose CPU is requesting K in the main memory, let's say it is at some 57th block. When this is requested, where it gets copied, it can be copied in any free block. Similarly, let's say CPU is requesting some P is from 112 block, let us suppose, where it can be copied in any free block. So PQRS I am copying in block number 15 in cache. Sir, how you decided? I have chosen randomly because I have a freedom to copy in any free block. So like this, if you copy, will you get a need to replace having a free block? No. So no need to replace if there exists a free block. So the miss that occur due to this replacement we call as conflict miss. Here such need will not come. So we can say in associative mapping, conflict misses are 0, not less. They never occur. They never occur. Okay. Now if you see the interpretation of address, the CPU generated main memory address is interpreted by associative mapped cache as just tag and word offset. What this word offset indicates? Block size or number of words in a block. So what is maintained as a tag by associative memory? Main memory block number is maintained as tag. Let us see. Suppose this is main memory. And this is cache memory. With 16 blocks. Now let's say I am copying word X, but I don't copy only that word. We know all block gets copied. Let's say I am copying that X block into block number 7 in cache memory, where this will be what is maintained as a tag once you copy. From which block it is copied? From block 1. How many blocks in the main memory? So number of main memory blocks are how many? 127, 128. That means 2 power 7 blocks are there. So there will be 7-bit value per block. So this 1 is maintained in the form of 7 bits. As X is copied from block number 1, that is maintained as tag. Krishna Seshank, maybe tomorrow or day after tomorrow I do a session. I or Malaysian sir will do session on that, score wise or marks wise mapping of IITs and NITs, with which score you can expect what IIT or what NIT. Okay, please wait for that. Just more 1 day or 2 days. We will give you proper guidance on that. Let's say I am copying the word K from some 50-second. So where I can copy in any free block. So let's say I am copying in block number 1. And once I copy its main memory block number, from which block you copied? 52, that is maintained as tag. So 52, I can say 32, 16, 48, 4. So 52 is maintained in this way. Now finally, suppose I am copying PQRS from 125, where I can copy anywhere. Let's say I am copying in 15th block. Once I copy, what is maintained as tag? Its main memory block number 125. So 125 I may write 64, 32, 96, 16, 112, 8, 124. So this is what 125. So as we are maintaining main memory block number as a tag, definitely that tag would be unique. So how many tag comparisons we do? Number of tag comparisons would be equal to number of cache blocks, because in the worst case with every tag you may need to compare. Here tag is not same. In DM it is same, but here tag is not same. So hit latency is high because it requires much time to compare all the tags. So with the DM, conflict misses are high, hit latency is less. With AM, hit latency is high, conflict misses are 0. So each has this contradictory pro and con, right? Reciprocal. So to balance these two, to balance this hit latency and conflict miss, we have got set associative mapping is used. We will discuss the set associative mapping in the part 3 tomorrow. Before that, how the questions can come. The question can goes in this way. Let CPU generate the address, 32-bit address. Okay. Let the cache size is 512 kilobyte. Block size is 32 bytes. Okay. Now, number of bits required for tag, block offset and word offset. For these fields, how many bits are required? The question can go in this way. So how we proceed? We know tag, block, word are given means it is a direct mapped cache. What is the interpretation? Tag, block offset, word offset. Always guys remember, when we are finding the number of bits, you should start from LSB, not MSB. Means first word offset, then block offset. Remaining will be tag. What word offset indicates? Block size. Right? Word offset indicates block size, that is number of words in block. What is block size? 32 bytes. When one word is equal to one block, 2 power 5 bytes, that means 5 bit for word offset. Now, what block offset indicates? Number of blocks in cache. It is not given, but cache size is given, block size is given. So number of cache blocks is equal to cache size by block size. So you will get 512 kilobyte divided by 32 byte. So you can say 2 power 14 blocks are there. So when there are 2 power 14 blocks, 14 bit per block offset. So how many are remained? If here 5 bits, here 14 bits, how many remained when the total address is of 32 bits? 32 minus 19, 13 bits. So number of bits left for tag is 13 bits, block offset is 14 bits and word offset is 5 bits. Right? So this is one of the popular model question from cache memory, direct map. All right. Before I conclude, let me introduce our pool of faculty. Mallesham sir, Murali sir, me, Ankit sir, Navneet sir and Anshul sir will be handling all these courses. And in 2020, 60 plus students have achieved in top 100. So take super subscription to enjoy all the structured live courses taught by best faculty, get all your doubts resolved. Along with this, you will get green card access with which you can attempt all the online mock tests, which is very, very important for any competitive exam practice. Okay. So see you tomorrow with this cache memory part 3, guys. A reminder about Gradeup app series data structures made easy, which is completely free. You may attend tomorrow at 6 p.m. and the next class on this series is cache memory part 3. So guys, thanks for joining. See you tomorrow. Till then, good night everybody. Prep smart, score better, go Gradeup. Thank you.